Please take this survey before you begin.
What is your gender? Male or female? Have you used virtual reality before? Yes or no?
Thank you for completing our survey. Press the check mark to begin the tutorial.
I'm here to guide you in this virtual reality simulation. I will give you step-by-step instructions like a GPS. You can also ask me any questions and I'll try my best to answer. Note that I am powered by the same technology that is used in Amazon Alexa. Although I do not know as much as Alexa does, I am learning more each day. Let's start by learning different interactions, such as teleportation and item interactions. To begin, we will learn how to move around. Press your thumb on the touchpad and point the curved laser toward the red target, release to teleport. Try this twice. Next, let me show you how you can interact with objects. Touch a button with your controller and click the trigger to press it. Try this twice. Use the reset button to reset objects that have fallen off the table. Hold trigger to grab an object, release to drop it. Try this twice. Point at the resize button and click to enlarge small objects. To snap an object in place, grab it and release it near the desired area. You are doing great. Let's put your skills to test on a stacking task. Can you please drag and drop the red cube onto the blue and yellow blocks? Great job. Now, please put on the glasses by first grabbing and then releasing near your head. Nice work. In this tutorial, you have mastered the following skills: voice commands, teleportation, and interaction. You are now ready to progress to the tensile test simulation. Click the checkmark when you are ready. Welcome to the Lab Student Experience. We will provide step-by-step instructions for you to use a CNC lathe to manufacture a chess piece from an aluminum bar stock. Wear safety glasses. To ensure safety, wear safety glasses at all times. Open the door of the CNC lathe by pointing and clicking the handle.
Here I will show you how to mount the workpiece on the CNC chuck. So we hold the workpiece in one hand and we make sure that it is sufficiently inside the jaw of the chuck. And with the other hand, we tighten the jaw with the help of the key. Please make sure that it is very tight, otherwise at high RPM there will be a chance of accident.
Insert the workpiece into the chuck. Touch the chuck key to the chuck to securely tighten the workpiece. Tightening of the workpiece is critical for avoiding an accident.
Okay, now we'll see how to mount this turning tool on the tool holder. We first put the tool in this groove of the tool holder and then we tighten the screws with the help of this Allen keys.
Insert the cutting tool into the channel of the cutting tool holder. Touch the Allen wrench to the screws of the cutting tool holder to tighten the cutting tool to ensure that the tool does not move during machining.
Now, the height of the tool should be aligned with the axis of the workpiece. So in order to align the height, we use the height gauge. The height of the height gauge is already preset with respect to the axis of the workpiece. We'll keep the height gauge close to the tip of the tool, and we'll use the screw mechanism in order to adjust the height of the tool and bring it to the level of the height gauge. Once the tool is aligned with the height gauge, we will lock the tool holder using this handle.
Place the height gauge on the station. Use the screw on top of the tool holder to adjust the height of the cutting tool tip. Pull the red knob of the lever to fix the cutting tool height. This step is important to ensure that the tool does not move during machining, thereby avoiding an accident. Remove height gauge, and put it on the table. Press the red emergency button on the control panel. The control panel can be resized. Press the power on button on the control panel.
Let us try and understand the coordinate system of the setup. This is the 00 coordinate of the machine, also known as machine 0. Now when we write a G code for certain operation, we assume Z0 at the surface of the workpiece with Z axis coinciding with the axis of the workpiece and X0 at the center of the workpiece. This is also called work 0. Before starting the operation, the tooltip should be at work 0. Therefore, we need to tell the machine how much it needs to travel in X and Z direction in order to bring the tool to work 0. This information is given by giving the offset values. In order to give the Z offset, we bring the tool close to the surface of the workpiece and try to touch it. In order to check that, we take a piece of paper and keep it between the tool and the workpiece and keep moving the tool towards the workpiece. Once the paper stops moving, we stop moving the tool and press Z distance measure, and the machine will automatically take the value of the Z offset.
Press the trigger handle jog button on the control panel to manually move the cutting tool. The jogging speed has been set to a default speed for you. Press the Z button on the control panel to enable movement of the tool along the Z direction. Now use the round jogging handle on the control panel to move the tool along X direction until it touches the circumference of the workpiece. Press the Z measurement button on the control panel to record the Z offset.
Now in order to set the X offset, we first need to move the tool away from the workpiece in Z direction and then move it in X direction so that the tool touches the circumference of the workpiece. We will use similar technique to touch the tool to the circumference of the workpiece. Once the tool is touching the workpiece, we press X diameter measure machine will take the value of the position of the tool and it will ask for the diameter of the workpiece. Now we will measure the diameter using a caliper. You can see that the diameter as shown by the caliper is 1 inch. So we will enter the diameter here, and this way our offsets will be entered and saved in the machine, and the machine is ready for the actual operation. Please remember that every time you change the workpiece or change the tool, you need to give the offsets again.
Press the X button on the control panel to enable movement of the tool along the X direction. Now use the round jogging handle on the control panel to move the tool along X direction until it touches the circumference of the workpiece. Press the X diameter button on the control panel to record the X offset. Pick the caliper and touch it to the workpiece to measure the workpiece diameter. Press the Enter button on the control panel to enter the measured workpiece diameter into the system. Pick the USB drive from the table and insert it into the control panel to transfer G-code to the CNC lathe. Close the door of the CNC lathe by pointing and clicking the handle. Press the Home button on the control panel to move the cutting tool to machine 0 location. Now the system is ready for CNC machining. Press the Cycle Start button on the control panel to start the cycle. Watch the machining process through the transparent window on the left door. Zoom in to clearly see the cutting process. Machining is now complete. Open the door of the CNC lathe by pointing and clicking the handle. Press the emergency button on the control panel. Press the red power off button on the control panel to switch off the power of the machine. Pick the chuck key from the table and touch it to the chuck to loosen the workpiece. Remove the workpiece and carefully observe the final shape of the chess piece that you have manufactured using CNC machining. Before you exit the lab, close the door and use the reset button on the table to return the tools to their original positions. Please rate your overall satisfaction with this VR experience. Would you like to see virtual reality applications in your other courses? Definitely yes, neutral no. Did you experience any dizziness while in? Congratulations, you have completed all the steps.